In this video, I'm going to demonstrate how to build a network diagram that will show traffic flows between two data centers. Let's imagine that we've got a couple of different customers that are procuring a service where applications are hosted in data center 1 and data center 2. So that's VMware infrastructure customer 1. Or virtual machine, doesn't have to be VMware, it can be any manufacturer. And then we've also got a VM infrastructure over here in data center 2, which is for customer 2. Now, if we explain how this is actually going to work from a customer routing perspective, let's get a couple of user icons. Users. I don't like that one actually. Let me just get a different user type. This one, AWS general user. Okay. So we've got the concept of the green users, which might access application hosted in VMware infrastructure 1. And then we've also got another set of users. If we make them orange, and they access the VMware infrastructure or application infrastructure for customer 2. And we associate that to orange. Okay, so the next step, we're going to put our WAN connectivity, wide area network connectivity in place. So let's say this is the internet. And then we have perhaps some firewalls. And that's a shared service. And these are active passive. And then in the other data center, we have a similar thing where we have the firewalls or firewall pair 2, which are shared. Oops, what I meant to do is that one's passive and this one is active. Okay. So then imagine we have a couple of routers. R1 and R2. And they're connected to the internet. Let me sort that out. Put this here. And this one here. And then I can just copy that. So I'm partially showing you how to create such a topology in Lucidchart as well here. Connection from router 1, router 2, and data center 2. And then you probably have something along the lines of this, and this, this, and this. Where I'll move these users up the stack a bit further. My OCD is taken over here on network diagrams. Let Let me zoom out a little bit. And you can see here that we're starting to build up a data center infrastructure that's connected to the internet. And there's some back-end applications. Now, what kind of questions would you need to ask from a network design perspective if you were to try and figure out what was going on here from an access perspective? So if this customer here wanted to access this application, or maybe they've actually got a replicated version of this application over here. If I put the diagrams in and say that that's in sync, so they're synchronized, and then by the same token, if the orange infrastructure or the orange VMware infrastructure which hosts the applications is also similarly synchronized like this between data centers. Let me just change that line type. Like so. Okay, so there's different ways that these types of data centers might be designed. So you might have like a single firewall pair at the front end. You might have actually another pair of firewalls at the back end. And then in between, you might have core routers, like so. Core routing, and then core routing over here. Where these are connected like that. 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 And then I'll do the same here. Core routing, core routing. Now, so what we've got here is like we've got internet access, we've got some internet facing routers in data center 1, and then data center 2 over the other side. And with this scenario, where do we take it next, right? So where we probably take it next is to decide what the layer is below the back-end firewall. Sometimes there will not be back-end firewalls, or they might be the same physical chassis, but these are virtual firewalls, or they might be on an NFVI infrastructure, so virtual networking infrastructure. But we'll just keep it simple here, and we'll say that there's front-end firewalls and back-end firewalls with core routing platform in between. Now we might also, before we step down to the next level, we might have like a data center layer 2/3 data center interconnect between this core routing platform. And again, that might be a dedicated circuit physically, or a pair of dedicated circuits physically, or it might be a virtual instance on a different shared circuit that is plumbed into this core routing environment. Let's go down a level and move all this down. If you look at this, what do you think that we might have here And is it core routing, or is it something else? Well, the answer is probably the data center switching core. So it's normally the spine at this layer. And then what we will typically have are still data center switching, but I'll just call it leaf nodes. So it's like spine and leaf architecture. Something like this. Let's move down the stack again. And you can see here, when I'm designing this, I'm really just getting the building blocks in place, and then where I can duplicate things, I do, to save me having to like redraw things out. So if we've got the spine leaf architecture, we might then have this, and this might be multiple links, okay? And this is only one way of delivering this type of solution. We might have, for example, redundant links to the green, but single links to the orange, depending maybe on the customer's requirements or what we've agreed to do for them. But obviously, standardizing your design, should be a key kind of objective. I'm just going to remove these for the time being, these duplicate links, just to keep it simple. Okay, when we've then built this platform to this level, and move this down a little bit again, we then need to decide how we're going to connect our leaf switches or spine switches to the rest of the data center. So the layer 3 out for the fabric inside the data center might go from a leaf, a border leaf node, or it might go like so, or it might come up from the spine like this. And there are different ways to achieve that with different vendors' equipment. So now that we've built quite a rough idea of what our two data centers are going to look like, you can see that we've got the data center interconnect, but if everything that I highlight in yellow is a stateful device, right? Or a stateful pair of devices. So these devices here. Now let's say that AWS user 1 typically comes to this cluster to access their application. Like that. Okay. And then everything's working fine. And the user is able to access their applications. There's no issues. And then all of a sudden, if I make that traffic flow a specific color, so everything is fine. And then what happens is an outage occurs. Let's just say these firewalls fail. I'll make that red for danger. Right, so let's say that fails. What we need to think about is then what happens next. We know for one thing, in general routing terms, right, that it's likely that the traffic is probably going to come over this direction instead of via data center 1 instead of data center 2. But then the question that we have to ask ourselves is then, what is the impact of that on the end user experience? So if this user is going initially through these firewalls that have had an outage, there's a few things that need to actually happen here in order to redirect the traffic. So DNS resolution has to happen because previously the DNS was resolving to the public IP addresses that were on router 1 and router 2's side of the network, or probably the outside. There was an outside NAT on firewall 1 and 2 for public IPs, and now the traffic is going to resolve to a DNS address which is on the outside of router 1 and 2 in data center 1 instead of the path that it was previously going. So we need to understand how the application is going to react to killing this connection, or this connection falling over through this stateful device on the outside, and then redirecting through the other data center. We then have to accommodate for getting back. Let's say the scenario. So we need. Sorry, let me go back. So we need DNS resolution, and then we need to reroute to DC1. Then application needs to re-establish state in new firewall, external front end firewall. That was a long bit of, yeah. I move that over here. Okay, so if these are steps that we're going through, right? So there's DNS resolution. Then we need to reroute from data center 2 to data center 1. The application needs to re-establish state in the new external front-end firewall. Then what we need to do is ensure that over data center interconnect, core routing platform, After this, we need to make sure I don't know what's happened here, bullets and numbering. But yeah, we route over the DCI. New session through backend firewalls, and then access application in DC2. All right, so that's the flow just for the green user. I'm just going to say customer 1 and then customer 2. Okay, and then if you imagine what I've just explained there and you drew like an application traffic flow, and let's say it was the reverse. So customer 2 accessed, by default, they accessed data center 1, like so. So and then they used data center 2 as the backup data center. In this scenario that I've explained failures, customer 2 would not be impacted at all by any of the failure over here. It would only be if they, I should probably change that line to something other than red. I'll change it to orange to suit them. So customer 2 would not be impacted by the failure that did impact customer 1. But what they would need is like the reverse of what I just explained for customer 1. So if this happened, then the reverse would need to be planned for like so. And then the blue line would actually still be going over the other direction. But you can see how this can become quite complicated. So if I take it back to both customers are going via data center 1, the thing that we need to ensure is, you know, from a design perspective, are these internet links are adequately resourced to have both customer sets, because this might be 1,000 customers with different infrastructure hosted on different platforms. The other thing that you might want to consider is if I take all these traffic flows out of the equation, and let's say that if we go back to customer 1 and say they access, if they access data center 2 by default, and they were a blue line, do this, they're a blue line, and they access data center 2 like this by default, and then if their stuff goes out of service, it might be that if any component fails, then the application also goes out of service. And this is where it's important to understand as a network engineer, if these applications, so if VM infrastructure for customer 1 in both data centers is completely synchronized, and if they look exactly the same at all times in both data centers, if that's the case, then what we can look at doing from a failover perspective is rerouting the traffic over here. So from a routing perspective, the traffic would reroute over here via data center 1 and all that through the internet. But when it hit the application, we would still need to make sure that, all this firewall state, so we would need to go through the same sequence. DNS would need to resolve to the new data center. We would need to reroute the traffic to data center 1 via routers 1 and 2. We would need the application to reestablish state in the new external, and then the only thing that would be different is instead of routing from data center 1 to data center 2 over this data center interconnect, this wouldn't be the case now, because what we're saying is the application is synchronized between the two data centers, and because that is the case, it's only the network devices that we need to make sure have state re-established. Because by the time you get to the application, from the user's perspective, you're seeing the same thing in data center 1 as you were seeing in data center 2. Even if you have to re-establish the session and maybe log into the application and things again, the data that sits behind the web application is going to look the same. Okay, so that's that video concluded. Just some design considerations on how to approach building a data center infrastructure, some of the things you need to consider, and then how you might want to think about things from a failover perspective specific to the applications. The applications always drive the network design. It's always been the way. It gets forgotten a lot, but you need to really pay attention to and understand at least the traffic flows of the application and how they interact with the network before you can develop a network design. And this will be included as a scenario in one of the CCDE tests that I'm developing for a global sports brand. So architectural overview, some VPLS routing, things like that. Now building up traffic flows in data center environments. The only difference is that I've done it live on a video and released it for you to see me building it up, but it will not be as easy as you see on the screen if you take the CCDE practice exams with MNB Networks. Thanks for listening. I appreciate it and take care. Cheers.